everyone. Hopefully everybody is having a good day today. We are back in the barn again. Today we are going to focus on applications of the normal curve. Last time we looked at the normal distribution or the normal curve. We talked about z-scores, we talked about the area under the curve, and now we're going to use what we learned last time to look at applications, which means word problems. So yes, this is the word problem section. So the first example we're gonna do is we're gonna look back to one that we did way back in the first couple weeks of school. So I'm gonna ask you if you remember the refrigerator problem. And we did that back when we were looking at Chebyshev's rule and the empirical rule with standard deviation. So I'll rewrite the information here, but hopefully this will kind of ring a bell a little bit. So we say the mean lifespan of refrigerators is 14 years with a standard deviation of 2.5 years. The data is normally distributed. Okay. Like I said, we've seen this problem before, but here it is in case you don't remember it. But in this problem, we are given a mean and a standard deviation. So the mean lifespan of refrigerators is 14 years. The standard deviation is 2.5 years. And then there's also a very important sentence that comes here, and that's the fact that the data is normally distributed. Now, normally distributed means that we have a bell-shaped curve. So back in whatever chapter that was, chapter 2, when we learned this, that meant the empirical rule. But now what it means is we can use z-scores, we can use finding areas, we can use what we learned in the last section in order to solve problems that have to deal with this. So I'm going to ask you a number of problems or a number of questions that deal with this guy. So first here, we want to find the probability your fridge lasts longer than 17 years. Okay, so find the probability your fridge lasts longer than 17 years. Now the best idea here, especially when you're starting off, is to draw yourself a little graph just to see what's going on. So we know that we've got the bell-shaped curve because it said normally distributed. So we got that guy going on. Now remember that in the real world, so in the X real world, the mean of 14 would be in the middle, and then we would measure out by 2.5s. So this would be 16.5, this one would then be 19, and this one would be 21.5. And we don't need to go the other way. Hold on, there's a dragon in my way here. And apparently a shovel. Okay, we don't need to go the other way because we're looking at more than 17 years. So 17 years would be about here. Label that little 17. And more than would be represented as shading an area on the graph this way. So remember that that probability and that area, they're the same thing. So the probability your fridge lasts longer than 17 years is represented like this on the normal curve. But here was the dealio. Remember, we weren't in the X world when we were using our calculator. Remember z-scores? So we need to use z-scores. Now again, way back in the first couple of weeks of school, we worked with z-scores. And maybe they're a little bit, you remember them, but here's the formula again, so that we can remember it, and we're gonna use it a lot. So remember that z is equal to x minus mu all over sigma. So when we're given a problem, we should have all the information we need to change our real world example into a z-score world example. So the x stands for the x that we're interested in. The value we're interested in is 17 years. We're going to subtract mu, which is the mean, so we're going to subtract 14, and then we will divide by 2.5. Now, very important here when you're plugging this into your calculator, remember the top has to happen first. So you go 17 minus 14 and hit enter. Okay, hit enter, then hit divided by 2.5. So enter after they do the top. Top, enter, divided by, and I got 1.20. Now remember that z-scores will always have 2 decimal places on them. So even though there's just that, I put the 0 on there just to help me remember those 2 decimal places. So now what we've essentially done is we've taken, sorry, that's not the most normal curve, but we've taken this real world example and we've turned it into a z-score. So a z of 1.20, and we're shading still this direction. So the only thing that should have changed now is this number line. The graph still looks the same. It's just that now this is a z-score rather than a real world number. Okay, from here, we need to find that area, and that's where we go back to our calculator. So hopefully you have been practicing with that. And so we need to do normal CDF, normal CDF, and then we're gonna go 1.2, and remember you go from left to right. So our z-score was 1.2 or 1.20, and then we're gonna go on towards infinity, but remember when we were going on towards infinity, we're gonna just put a 10,000 there, and that should take care of it for us. And what should pop out is 0.1151. And last but not least, we gotta label this. I also want you to notice that the common form is to have 4 decimal places there, so 1151 is the common. And so we would say the probability that x is greater than 17, right? That's what we want, longer than 17, is equal to 0.1151. So there's 11.51% chance that your refrigerator will last longer than 17 years. Okay. All right, so remember that normal CDF is underneath the distribution key on your calculator, so you have to go second. So you have to go second, and then this distribution key over there, and there's your normal CDF, okay? Okay, so that's our first example there. Let's do another one. We're gonna still use the same refrigerator setup. I'm just gonna give you a new problem here. So here's our second problem. So this one says, find the probability a fridge lasts between 13 and 22 years. 13 and 22 years. Now, again, we could go up here and we could do this all on the real world number line and plot a graph and do everything. Or we could make that jump and say, wait a minute, this isn't gonna work for us. We wanna use z-scores. So we need to turn 13 into a z-score, But we also need to turn 22 into a z-score. So there are multiple z-scores in this problem, and we can jump right to that step. So find z's. So for the first one, we'll use the 13. That's our x value, so 13. We're still subtracting our mean, which was 14, and then we're dividing by 2.5. So remember, again, that is going to be 13 minus 14, hit enter, and then divided by 2.5. And for this one, I got negative 0.40. Okay, top first, hit enter, and then divided by. And then the other one, we need a z-score for 22, so we'll go 22 minus 14 divided by 2.5. 22 minus 14, boop, enter, divided by 2.5, gives us 3.20. 3.20. Okay, so we end up this time with, like I said, 2 z-scores. So if we want to draw our little graph, just to kind of visualize it, for those of you that like to see the visual, it never hurts to draw a little graph and see it visually. It only helps you. So this guy, though, is over to the left-hand side, so negative 0.40. And this guy is way over here, 3.20. And these are z-scores. And this says we want the probability that it's between. So that's represented by an area between. So on this one, you're going to go to your normal CDF. And we're going to start at the negative 0.40, comma, 3.20. Okay, so this time we have endpoints on either end, so we just put on our endpoints. And hopefully what pops out is 0.6547. Okay, plug that into your calculator. Doop, 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 doop. See if that's what you get. Now remember, this doesn't mean much to people in the real world. If you said to someone, well, normal CDF is 0.6547, they're gonna be like, what the hell does that have to do with my refrigerator? So we definitely don't leave it like this. So we label by saying the probability that we are between 13 and 22 is equal to 0.6547. All right, so remember, every answer has an appropriate label to it, not the label that comes from your calculator, but an appropriate label. Okay, let's look at another one then. Still using our refrigerator problem. This is probably the last time with the refrigerator problem, then we'll move on. Okay, third. Whoops. Sorry everyone, that was two crazy dogs coming in. Hold on, let me get you lined up again. All right, well, you never know what's gonna happen in the barn. Okay, so back at it. So here, this says fridges with a lifespan in the bottom 3% fall under the warranty. What is this lifespan? So everybody's always asking, you know, when am I going to use this math? How does this apply to me? And this is the perfect example of how statistics applies to you. Now, statistics applies to you in all sorts of different ways. We've talked about many different ways. Here's another one. So anytime you buy something that has a warranty, like has a year warranty or a 5-year warranty, or like a car with a 100,000 mile warranty, that all has been calculated using statistics, doing exactly what we're doing right here. So what they're saying is the fridges that last, or that have a lifespan in the bottom 3%, so they're not going to last, those fridges aren't going to last very long. The company is willing to give a warranty. Either they'll repair the fridge or give you a new fridge if you get one of the crappy ones. But they have to decide what that lifespan is in order to give this warranty. But they also don't want to give a warranty where they're giving away tons of new refrigerators. It's got to be like the bottom little bit. So I just used 3% just to use something other than like 10 or 5 or 1%, just to kind of mix it up a little bit. Okay, but the idea here that's different than what we did in the last two examples is that this guy is backwards. In this one, I have given you the percentage and I want to know what the lifespan is. In the last two, I gave you the lifespan and I wanted the percentage or the probability. So this is definitely backwards. So when we look at our graph here, I haven't given you any numbers on the number line at all. What I've done is I've given you an area and I've said the bottom 3%. So hopefully we can all agree that this looks like the bottom 3%. So we'll say this is the bottom 3%. Okay, now, if you remember from last time, what we were working with is we can go both ways. You can use the normal CDF to find an area, or the other one that we used from our calculator was the inverse norm. So remember that the inverse norm calculation, it always gives you a left tail. Now the nice thing about this is, don't we have a left tail? Isn't that a left tail? So we're perfect. So all we have to do is go inverse norm, and then don't use 3, put it into decimal form, 0.03. And just in case you don't remember, the inverse norm is right next to the normal CDF. So if you go, sorry about that, second distribution, there's the normal CDF, and then inverse norm is right underneath it. Our area is 0.03, cycle down, boop, boop. And I get a negative 1.88. Right, so what this has done is we put in the area, and this, the inverse norm, gives us that z-score. So we know that z equals negative 1.88. So we're working our way backwards. Now, it would be nice if we were done, right? We got the z-score, that's what we wanted, but wait a minute. We're not in z-scores in the real world, we're in refrigerators. So we're not quite done yet. We still need to go backwards a little bit more. So I'm gonna write down our z-score formula. Mu over sigma. Here's our z-score formula. We need to figure out what x is. That's what we're looking for. That would be the lifespan. I have z, and I have those two pieces of information. So if we plug them in the correct order, we will be able to find out what x is if we use a little bit of algebra. So our z was negative 1.88. We don't know what x was, so we'll leave that as our variable. Minus 2.5, wait a minute, did I screw that up? I did indeed. What was our mean? It is not 2.5. Minus 14 over 2.5. Alrighty, and here comes some algebra skills. So to get that x alone, we're gonna multiply by 2.5. So we'll go times 2.5. and then boop, boop, and then we will add 14, and then we will figure out what we got. So multiply first by 2.5 and then add 14. So negative 1.88 times 2.5 plus 14. I got 9.3. And this, we're back in the real world, so we'll definitely label it 9.3 years. So apparently if your refrigerator is in the bottom 3%, that's bounded by 9.3 years. So if your refrigerator lasts less than 9.3 years, you're gonna get some sort of warranty for it, in my world, okay? That's nice, isn't it? Okay, so if your refrigerator stops working, you get a warranty. You get a new one, or we will fix it for you. Okay, so we're seeing how we're going from the real world using z-scores to the normal curve where we can find areas and probabilities. So we will keep on with that. Let's do a completely new example this time. Okay, totally made up. I've just made this problem up. So this says the mean time spent washing your hands is 23.4 seconds. With a standard deviation of 4.1 seconds. The data is normal. So again, like the last one, they tell you what we're studying here. This time we're looking at the time spent washing your hands. They give us a mean and a standard deviation, and then this is very important. When it says normal, it means we can draw that curve. If it doesn't say normal, we cannot do this problem this way. So that normal allows us to continue on. Okay, so let's see what we have this time. First thing I'm going to ask you to do is to find the probability a person spends fewer than 15 seconds washing their hands. Now, another thing, now that we've done one full example and we're starting on the next one, if you would like to pause the recording right now, you can practice the problem yourself and then go through it with me and see if you got it right. So, use this video to help you, almost like a tutor. So like, let me guide you, but see if you can do the steps first, and then when you need help, go through the video. Okay. All right, so we have our question. Now, they want us to know the probability a person spends fewer than 15 seconds. So they've given us a real world number, which means we first need a z-score. Now, the other thing about this is once you've done one problem and you move to doing another problem, remember to switch gears. The numbers are no longer the same up here, are they, right? This isn't the refrigerator problem. So we're gonna say our x is 15, but this time we're gonna subtract 23.4, and we're going to divide by 4.1. Now, as always, remember, top first, hit enter, 15 minus 23.4, boop, divided by 4.1, and I get a negative 2.05. Now remember, this is decimal, goes on for a lot of decimal places, but z-scores always have 2 decimals, so you can always round that just to that second decimal place there. Okay, then remember we can draw our graph just to make sure we see what's going on. So a negative 2.05 is over on this side. And think about that for a second. This is the middle, right? 23.4 seconds is in the middle. 15 is definitely less than. So does it make sense that we're on this side of the graph? And we want to go even fewer, so we're shading this way. So if you go to your calculator, again, we're going to use the normal CDF. But this time, our left boundary is going to be way off towards negative infinity, or negative 10,000, comma, negative 2.05. And this time, I got 0.0202. So remember, don't leave your answer like that. Make sure you just finish it off real quick. So this then would be the probability that we are less than 15 seconds, be 0.0202. So, second one, still with the same example here. So the second one, let's say the top 10% of hand washers won't get sick. How long do you have to wash your hands to stay healthy? Okay, and I'm gonna remind you, I made these up, okay? It would be great if the top 10% of hand washers didn't get sick, but just remember, totally made up problem, okay? Okay, so the top 10%, now, what am I giving you this time? If I'm saying the top 10%, aren't I giving you an area? So the first thing we're gonna do is draw our graph and see what the top 10% might look like. So could that maybe look like the top 10%, or 0.10, okay, for 10%, okay, 0.10. Okay, so this is another one where we're going backwards rather than forwards. I've given you an area, I want you to go backwards and give me the number that goes with that. So this one, instead of using the normal CDF, we're gonna use the inverse norm. So we're gonna go inverse norm, but I want you to remember this is the one where there's definitely a quirk, right? Because this guy always works with a left tail. So if this is a right tail and it's 10%, what's the left tail that goes along with it? What's the complement? And wouldn't that be 90% or 0.90? So I need you to plug in 0.90 to get the correct answer, okay? So don't plug in 10 or 0.10, plug in 0.90. I guess that looks weird. There we go. And if you do that, we should get a positive 1.28. So we now know that that little z-score is equal to 1.28. But is the z-score what I was really looking at? The question said, how many seconds do you have to wash so that you won't get sick or so that you'll stay healthy? So we need to turn that back into a real world X value. So that's where we're going to use our z-score formula, but we're going to plug in the 1.28 for z equals x, because we don't know what x is, minus our mean, divided by our standard deviation. So again, this is your algebra. So we're going to go times 4.1 times 4.1. That gets rid of that guy. And then we're going to add 23.4, add 23.4, and that gets rid of that guy. So we end up with x equals 1.28 times 1 plus 23.4. So I got an x of 28.648. 28.648, and then remember that this is now in the real world, so we are in seconds. So in order to stay healthy, you've got to wash your hands for more than 28.648 seconds. All right, a little bit more here. So again, going way back to like, I think it was chapter 2, we talked about percentiles, and we only talked about them. We didn't do any calculating because what we really talked about there were the quartiles way back when we were doing the box plots. But we did talk about percentiles, and we talked about how percentiles compare you to the rest of a data set. So we say like to be in the 80th percentile on a test doesn't mean that you got an 80% on the test. It means you did better than 80% of the other students, okay? So remember, it's a little bit different there. And we didn't calculate them because at that point, there really wasn't a proper way to calculate them. But now that we have our normal curve, percentiles come back into play. So here we go, percentiles. When we measure percentiles on the normal curve, the thing to remember is that they are always measured as a left tail. So whenever you hear percentile, you think left tail. So percentiles are always measured as left tails on the normal curve. Okay, so as an example, let's say that you were in the 23rd percentile. So the 23rd percentile, if we were going to represent that on the graph, is always going to be shaded from the left. So you're always going to shade in from the left. And what we need to do is shade 23% of the graph. So if we go to the middle, that's 50% of the graph, right? So maybe if we shade like to about there or so. That might be about 23% of graph. Remember, it's not to scale or anything. But this part here is 0.23, or 23% of the graph. If we were said that we were in the 81st percentile, now we're still going to shade from the left, always left, always left. But this time, if here's the middle, if we start shading from the left, how far are we going to go? So middle is 50%, so we need 81%. So we're gonna go maybe like over to here. That, everybody agree? So 50% is in the middle, across the middle, again, not to scale, don't worry about it, but this whole area here is 0.81. So it means that you have to pay attention to the question, and remember that whenever it says percentile, left tail, percentile, left tail, you just have to remember that. So here is our example. So this says the mean score on a test was 76.4 with a standard deviation of 5.3. The data is normally distributed. Remember, that's still very, very important in this section. Everything's got to be normal in order to continue to do the problem. Then the question says, if you scored 85 on the test, what percentile are you in? So this time they're giving you the score and they want you to tell them what percentile you're in. Now, percentile, again, is just another way to say area. It's just another way to say left tail area. So if we know in the real world your score was an 85, then just like we've done in the other examples, the first thing we need to do is turn your score into a z-score. Okay? So we're going to find z if our x is 85. We'll subtract our mean, which in this example now is 76.4. And we will divide by our standard deviation of 5.3. So 85 minus 76.4, enter, divided by 5.3, top first hit enter, and I end up with a 1.62. Okay, hopefully you ended up with a 1.62 as well. So we put the 1.62, which would be somewhere around here. We put that on our graph, and because it's asking us about percentile, which way do we shade? We go this way, don't we? Left tail, percentile, left tail. So what we need to do is find the area of that tail. So we're back to a normal CDF. And remember, we're looking to the left, so our boundary over there is going to be the negative 10,000. And then comma 1.62. So plug that into the old calculator, and we should end up with 0.9474. So hopefully that's what everybody got. Now here's where things change a little bit. Normally at this point I would say, all right, you have to give it a nice label. But our label here is a little bit different because it's asking us for a percentile. So this answer is our percentile, but it's not in percentile form. So we have to do two things, okay? The first thing is that we need only 2 decimal places. We don't want those last 2. But here's the thing. We are not going to round. If you remember again back from the first or second chapter, we're going to truncate. So remember, to truncate means to just cut off decimal places without rounding. So we don't want these 2, so we're just going to go, don't round, do not round. Now what we need to do is move this decimal over and write it in percent form. So 94th percentile. So if you scored an 85 on your test, you are in the 94th percentile. Okay, so remember that. When you find this area, if it's a percentile problem, you truncate off any extra decimals besides those 2, turn them into a whole number, and put the on there. All right, one more of these guys. We'll still use this same example here. So this one says a student in the 44th percentile got what grade on on the test. So this time we know that the student is in a particular percentile. So we're told, so you get your test back and it doesn't have a grade on it for some oddball reason, but it tells you that you're in the 44th percentile. So we have to use some math to figure out what grade you actually got on there. So again, we draw ourselves a picture. Now what have we been given here? Have we been given like a z-score or have we been given an area? And because we're in the 44th percentile, that is an area, isn't it? Now I want you to think about this. If you're shading from the left, the 44th percentile, are you gonna go all the way to the middle or over the middle? Or are you just a little bit on this side? Okay, so we'll say that's 0.44 or 44th percentile. Now remember, we're going backwards, so this is where you're gonna use the inverse norm. And the nice thing about percentile, it's a left tail, which is exactly the way inverse norm works, so life works nice and easy here. You just put in 0.44, and then we see what pops out. I don't have this one written down, so I will do it right along with you. Inverse norm, 0.44. I got a negative 0.15. Now remember, this is a z, and this is our z-score. So they're telling us that z equals negative 0.15. But we want to know what the actual grade was on the test, so we're going to use our z-score formula backwards to figure out what the x is. So we're going to let negative 0.15 equal x minus the mean, which was 76.4, all over the standard deviation, or 5.3. And then one more time, we're going to use our algebra skills, multiply by 5.3. Gets rid of that. And then add our 76.4, gets rid of that, gets rid of that. Now, obviously not proper, beautiful notation here, but we're in stats class, not in algebra, so we'll just go with it. Okay, let's see. Negative 0.15 times 5.3 plus 76.4. So I end up with 75.605. And remember, this is the test score. So if you get your test back and it says that you're in the 44th percentile, now at first glance that doesn't sound so good, does it? You go, God, 44th percentile, it means you only scored better than 44% of your class. But if you actually look at that, are you still in a nice passing grade? Sure, that's a nice passing grade. Okay, so the 44th percentile, remember that has nothing to do with your actual score. Just tells you where you fell compared to other people. But in this case, that's a perfectly good grade to have. Okie dokie, so we've done a number of different examples. So we've gone forward, we've gone backward, we've done percentiles. So remember that you read the problem carefully. Remember, drawing a little picture is always helpful. It just kind of helps you decide which way you're shading, that type of thing, less than, more than, you know, percentile, left tail. And you just slowly but surely work through these problems using your z-score formula, your calculator, and the little graph. Okay. All right, so practice this a lot because the next section gets a little bit uglier. Okay, so make sure you do enough practice of this so that you feel really firm on it. Okay, everyone, have a good day.